Hello, this is AMET 104, lecture recording week 9.2. So last time we started on the chapter 16.1 and we mainly looked at different new terminologies and their definitions, and we only looked at a few different examples. Let's first define things before we do anything today. So just define two things. So sample space is simply the set of all of its possible outcomes. And it's often denoted as capital S. And we also looked at the definition of an event, which is a subset of the sample size. And let's say any subset of sample size, meaning that it could consist of anything. As long as it's a subset, we consider it an event. And this includes the impossible event where there's no possible outcomes. This also includes the entire sample space. And we looked at an example last time. So today we are going to mainly spend time going over different examples that you might encounter, and most are pretty straightforward. A lot of them are just wordings, and it can be quite confusing, but it really shouldn't be after a few examples. You should understand the pattern that they're asking. So without further ado, let's start with the example. So find the sample space. So using set notation, write out the sample space of the following. And the first problem will be a coin is tossed. Four times in a row. And the observation is how a coin lands. So in other words, you get heads or tails, like that. So if we denote the heads as heads as H and tails as T, we can simply write the set notation first. And we start with, we can get all heads by tossing 4 times. We can also get 3 heads and a tail. We can get heads, heads, tail, heads, heads, tail, heads, heads, and tail, heads, heads, heads. And these were all 4 that include only one tail. And now let's go over to two tails. So we have heads, heads, tail, tail, heads, tail, heads, tail, heads, tail, tail, heads, and we have tail, heads, tail, heads, and lastly we have, oh, it's not the last, I guess, tail, tail. Let me write it in the below here. Tail, tail, heads, heads, and we have tail, heads, heads, tail. I think those are all the possible outcomes with two tails. We could have three tails, which would be heads, tails, 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 heads, tails, 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 heads, tails, 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 heads, and lastly we have tails, 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 tails. So I think those were all the possible outcomes. So we know that we talked about the sample size last time. And in this case, we know that for each toss, there can be two different outcomes. You can either have heads or tails. And since there are four, you can simply exponentiate by 4. That's the same thing as saying for the first toss, you can either get tail or heads. You have two different options. And for the second one, you can have 2. For the third one, you can have 2. For the fifth one, you can have 2. And hence you have 16. So we can, so when it comes to writing out all different, the entire sample space, it's possible that we may miss one or two outcomes because we may lose track. It's always nice to check the sample size and count how many there are. And I think I got everything here. So now let's look at the different example. So next example is a basketball player shoots 2 consecutive free throws. And here the observation is result of each throw. So observe result of each throw. In other words, we're gonna use the terminology success or failure. So oftentimes when we are given things like that, obviously when somebody says, oh, a basketball player shoots 2 consecutive free throws and what's the sample size? It's possible that they may be asking for the outcome in terms of the scores. So either scoring both, only scoring one, not scoring at all. Just to avoid all the confusion, homework problems will say what we're really observing. And most examples, most problems that you'll encounter on Pearson regarding this chapter will be multiple choice. So hopefully that will not be an issue for most of you. So the sample space, knowing that we're looking at either success or failure, the player can score first and second. The player can make the first goal, but don't make the second one. It can happen other way around. The player can miss the first one, but make the second one. And lastly, the player can fail both. And that was quite simple. C, so a coin is tossed 4 times in a row. And we're observing, let's say, number of times tails, the coin comes up tails. So if you compare the C and A, the experiment is the same. Here we're tossing the coin 4 times. However, the observation, what we were observing in the first case is the how a coin lands. So we're writing down if the first came down with heads, tails, and that's all we're doing. And for this example, example C, we're more interested in how many times the coin came up tails. So we're only counting the number of tails, but not heads. So instead of using the notation of H and T, we are going to say there can be no tails, there can be 1, there can be 2, there can be 3, and lastly, all 4 could be tails. You can think of it as you're simply just counting the number of tails after after tossing a coin 4 times. Similarly, what if the problem asks a basketball player shoots, let's say in this case 3 free throws, consecutively, and we're more interested in the number of success. So number of success. In other words, we're counting the number of the score that the player yields. So out of the 3 free throws, the player can make all 3. So that'll be 3 goals. Can only make 2. And also can only make 1. And lastly, the player may miss everything. And that's it. That's really all you're being asked. Let's look at a few more examples regarding random experiment and sample space. Let's say a student randomly guesses let's say 4 true or false questions. And we're more interested in the actual choice. So here, we don't know if true is true. I mean, if which choice is the correct answer. We don't know if true is the correct answer for which problem. So here, we're only going to look at how the problem is answered. So out of 4 true or false questions, the student can answer all 4 true, because simply they are guessing everything. And student can answer 1 false, and that's going to be expressed like this. And this can also happen because order matters. Like that. And there could be, student may have chosen 2 true and 2 false. True, true, sorry. True, false, true, false. False, true, true, false. True, false, true, false. Oh, we already done that, sorry. This gets quite confusing after a few times. And there can be false, true, false, true. And I think there can also be false, false, true, true. And I think that's all. And we can also have 3 false. And that includes false, true, false, 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 true, false, and false, 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 true, and lastly, all 4. I think that's all we have here. I may have missed a few, I feel like. We also, I think we missed the, no, we didn't. So let's actually count. So we have, oh, we actually got everything. So we have 16 here. So we have 5 up here, 6, 5. So it's 16. It's a total 16. And we can confirm that the sample size would be, for each problem, the student can answer true or false. So there are 2 choices. And since there are 4 different events that the student has to choose, you simply exponentiate by 4, and that's going to be 16. And we can confirm that there are 16 elements in this set. Let's look at one more in terms of this specific type of problems. Let's say, let's actually keep the problem. Let's say the student is still choosing, guessing the 4 true or false problems. So the same thing. So a student randomly guesses for true, false questions. And in this, so it's the same, but in this case, we're interested in the correct answers. In other words, we want to know the percentage of the student's test. So here, this can be a quite tricky problem for a lot of you, but it really isn't. So we do not know for each problem which choice is the correct answer or not. But we know that there are 4 problems, and out of the 4 problems, whatever the choice the student made, they can get it wrong or right for each problem. So if student gets none of the problems correct, the student will end up with 0%. Out of the 4 problems, if student gets 1 problem correct, they will end up with 25%. If student gets 2 correct, 2 wrong, that'll be 50%. And if the student gets 3 correct, but not 1, that's going to be 75%. And lastly, if they get everything correct, it'll be 100%. So I think that was pretty straightforward, and I think that was enough example for sample space. Now let's go over to different examples for the events. So let's look at the events. So we're gonna do the write out the event described by following. So let's say the first one says the actually that's not a very good start. So here because the event is a subset of a sample space, we have to denote the sample space first. And here the scenario is that the coin is tossed 3 times. And that's the scenario. This is the sample space that we're looking at. And the problem A would say the coin comes up heads exactly once. Let's say that. We know that the entire sample space here in this case would be heads, 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 tail, heads, tail, heads, tail, heads, heads, tail, tail, heads, tail, heads, tails. We can have tail, tail, heads, and lastly we can have all tails. it is always easier if you write down the sample space like this. So out of all these possible outcomes, we want to look at out of these what consists of the coin comes up heads exactly once. So obviously, if you look at the first row, heads come up at least twice or 3 times. So we can look at tail, tail, head, and we have tail, heads, tail, and there's tail, tail, heads, and lastly, oh, there's no tail, 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 because that's really all we're looking at. So that is what the problem A is asking for. So let's keep the same scenario. Let's say we're still tossing a coin 3 times. And now what we're interested in is all coins, so all 3 tosses, come up the same. So from here, we know that we can have heads, 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 and we can also have tails, tails, tails. And that's it. There's those are the only 2 possible options. Now let's look at the next one. Let's say this one says exactly half of the tosses come up tails. So here, we're tossing the coin 3 times. So it wouldn't make any sense to have half comes up tail, or I mean, half comes up tails, because that would imply 1.5 times. So in this case, this is not possible because there's no, so half of 3 is not a whole number. So we can simply say this is an impossible event. And often it's just denoted like this, just squirrely braces without anything inside. And let's look at one more. The first toss comes up tails. So we're only looking at the first toss. So as long as the outcome starts with T, that's what we're interested in. So we have tail, heads, heads. We have tail, tail, heads. We have tail, heads, tail. We have tail, tail, heads. And we have tail, tail, tails. Yeah, I think that's it. So those are all the possible outcomes when we get 3 tails. Oh, these 2 are the same, sorry. This is the same thing. Yep, I think that's correct. Now let's look at a few more examples. Let's do one more scenario. Example. We're doing the same thing. We're interested in the events. We're looking at the events. Let's say a student randomly guesses the answers to true or false questions. Let's actually make it a little more complicated. Let's say it's 4. And we're interested in the following events. Let's say that for the first one, student answers T to 2 questions. Meaning that out of the 4 problems, student chooses true twice, false twice. So we can have true, true, false, false. We can have true, false, true, false. We can also have true, false, false, true. And false, true, false, true. And lastly, we have false. No, that's not the last. False, false, true, true. And lastly, we have false, true, true, false. In this case, the order that you put down these events is not important as long as you include everything. Let's look at next example. Let's say now we're interested in student answers T to at least 1. So this means, in other words, so there are different terminologies that you'll encounter a lot in this chapter. One is at least, the other is at most. When we're dealing with those languages, it's very important to understand what it exactly means. So when it says at least 1, it could be 1, it could be 2, it could be 3, it could be 4, and that's very intuitive. Or in other words, what it doesn't mean is when there's no true at all. So instead of trying to write down every single one by one, it may be easier if you just exclude the complement. So the complement in this case would be when the student doesn't choose true at all. And we can simply exclude that from the entire space, and that's simply the answer. So let's actually write down everything, and hopefully we don't miss anything. We have true, 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 true. We have true, 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 false. True, true, false, true. True, false, true, true. Let's do true, true, false, false. true, false, true, false. True, false, false, true. True, false, false, false. And we can have false, true, true, true. False, true, true, false. False, true, false, true. False, true, false, false. False, false, true, true. False, false, true, false. False, 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 true. And I think that's it. So there should be 15, I think. Yes, there are 15. So the reason why there are 15 is because, so n is 15 because the sample size for the whole event is 16, meaning that there could be 16 different outcomes from this event. And there is only one event where the student answers with no T. And this is what we were talking about in terms of complement. And we're going to look more into the terminology of complement more, but not now. And namely, in this case, it's the false, 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 false. Since that's the only outcome, we take away one from here and rest should be in here. Let's do one more since we looked at the at least. Let's look at the at most. So the student answers T to at most 2, let's say. So this implies, as the language suggests, it means that student can answer no T, meaning all false. Student can't, they can answer with 1 T, so 3 false, or 2 T's. And just to write everything down, it's going to be true, true, false, false, true, false, true, false, true, false, false, true, true, false, 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 true, true, false, false, true, false, true, false, true, false, 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 true, true, false, false, true, false. We have false, 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 true. And lastly, all false. So as you can see, all the choices that we have no more than 2 true in each of the choices. So really, the problems can be really elaborate. It could be very creative, and it could be very tricky. But it all really comes down to how much time you spend on it, and make sure you do not miss any of the elements. And in terms of the difficulty and the level that we're dealing with, it really shouldn't be any difficult. It should just be the wordplay. And if you read the problem a few times, it really shouldn't be any problem. And also because all the homework problems are online, the only types of problems that they can give you is these types of problems, and they are mostly going to be multiple choices. So you can simply skim through and filter out the things that is clearly not true, and instead of worrying about missing 1 or 2 elements, you can simply just look at the choices that you're given. So I think that's enough examples for this chapter, and I think I'm going to call it a day today. So next class, we're going to look at chapter 16.2. It's about the multiplication rule, permutations, and combinations. And there are a few different new topics that we will go over, but it should be fine. But make sure you understand this chapter 16.1 because this is the fundamental part before we go into anything elaborate. So that's it. Thank you for joining the class, and I hope you have a great rest of the day.